Hello students, I hope you're having a great day today. Today we're going to talk about solve measurement problems. So there are lots of problems in the real world that we have to do with measurement. If you want to know how much fence you need to go around your yard, you got to have measurement. If you want to know how much flour to put in your famous chocolate chip cookies, you've got to have measurement. So every day we use measurement in different ways. But why do we convert measurements? Once again, I want you to go to Schoology and respond. First, you're going to respond to the discussion, and then you're going to read to others. Come back and finish the recording. So when I say go, I want you to pause this recording. Go to Schoology, you're going to respond to the discussion, and then you're going to read 2 other discussions. All right, go. All right, so hopefully you had the chance to respond to the discussion in Schoology and to read 2 others. You know and remember that the teacher gets notifications every time something is posted in Schoology by her students, and the teacher can read everything that is posted in Schoology by her students. So let's be wise about posting. Make sure you're following directions and doing what I've asked you to do. All right, for our problem of the day, we need to write 2 decimals to describe the shaded part of the model below. So I'd like you, if you need to pause this recording again, go and get your math journal and come right back. All right, so this grid that we have right here, we need to write 2 decimals that describe the shaded part. We can write our decimals in tenths or in hundredths, right? This whole thing equals 1/100ths because each of these little squares represents 100th. So we can either say, well, first we can say how many little squares are shaded. Well, I can count them individually, like 1, 2, 3, 4, 5, 6, 7, 8, 9. Or I can say, well, this is 10, 20, 30, because I know that there are 10 in each row. So 10, 20, 30. So the decimal for that could be 30 hundredths, 0.30. That equals 30 hundredths. Okay, another way we can write this is to write what? Think for a second. These are divided into 10 rows, like we said before, which made it easier to count by tens. So these are also tenths. So how many tenths do we have here? Well, I can see that this right here is 1/10, 2/10, 3/10. So another way that I can write a decimal to represent the shaded part of the model is 3/10 or 0.3. That also means 3/10. So here's our Common Core quick check to review what we did yesterday. This says the line plot represents fractions of an hour that Mindy read a book each evening last week. Use the line plot to answer the questions. Okay? So, here are questions. Which interval of time did Mindy read most frequently? Well, if I look at my line plot right here, Mindy's reading, there are no x's over the 0. There's 1 x over 1/4. There are 3 x's. Do you see this? Over 1/2, 2 over 3/4, and 1 over 1. So, the interval of time that she read most frequently was the one with 3 because it has the most options there. So 1/2. Okay, what is the difference in total time spent reading during the 1 hour time interval and the 3/4 hour hour interval? Okay, so it wants to know what is the difference between 1 and 3/4. Well, we know that 1 is also 4/4, so we can subtract 3/4 from 4/4. and that equals 1/4. So 1/4 is the difference between 4/4 and 3/4. Okay, what is the total time Mindy spent reading last week? All right, we need to go back to the chart, and we are going to have to add these fractions together. So we've got 1/4, 1/4, right? So 1/4 plus 3 1/2. So plus 1/2, plus 1/2, plus 1/2. Whoops, went too far. Plus 2 3/4, plus 3/4, plus 3/4, plus 1 whole, right? Yep, plus 1 whole. So we have to add all of these fractions together. What I'd like you to do is pause the recording and solve this problem in your math journal. Pause now. Okay, so to be able to effectively add fractions, we have to have common denominators, right? It looks like we have a 4 for this denominator, 4 and 4. And we can actually change this to be 4/4, because 4/4 is the same as 1/2. So I need to get my 1/2, I'm sorry, 4/4 is the same as 1 whole. I need to get my 1/2 to equal something with 4 on the bottom for my denominator. So the way that I can get 4 on the bottom right here is to multiply by 2. So I'm going to multiply each denominator right there by 2, and if I do it to the bottom, I have to do it to the top. So now if I rewrite what I have 1/4 right here, 1/4 plus 1 times 2 is 2, 2 times 2 is 4, so 2/4 plus another 2/4 plus another 2/4 plus 3/4 plus 3/4 plus 4/4. All right, so now that we have all common denominators across the bottom, we can add our numerators. So 1 plus 2 is 3, plus 2 is 5, plus 2 is 7, plus 3 is 10, plus 3 is 13, plus 4 is 17. Did I do all that math right? So 17/4. Whoa. Okay, so now I'm going to erase what we have up here so that I have some room to figure out what 17/4 equals, because that is an improper fraction. We need to change it to a mixed number. So 17/4. 4 goes into 17 how many times? Well, 4 times 4 is 16. That's a good size for it. So 4 times 4 is 16, with 1 left over to get to 17, and 4 is what's left, or our denominator. So 4 1/4 hours she spent reading that week. Okay, now next we have the question, how do you solve problems using or involving customary measurements? Okay, well, customary measurements are, remember with me, gallons, cups, pints, quarts, also inches, feet, also yards, miles. We've got others too for weight, like pound, ounce. Okay, those are customary measurements. So anytime we have customary measurement, we need to still work with customary when we convert it, unless it's asking us to convert it to metric. Okay, so Tyler is making a recipe that calls for 8 ounces of mushrooms, 12 ounces of ground beef, and 1 1/2 pounds of tomatoes. About how much will the dish weigh in pounds? So we can create a table converting pounds to ounces. Okay, we know that there are 16 ounces in 1 pound. Okay, so what is 1/4 of 16? We know 4 times 4 is 16, so 1/4 of 16 is 4. All right, what is 1/2 of 16? 1/2 of 16 is 8, because 8 times 2 is 16. What is 3/4 of 16? Well, 1/4 of 16 is 4, and 4 times 3 is 12. So 12 ounces is 3/4 of 16. And then 1 pound equals how many ounces? 16, right there. Okay, so here is our table converting pounds to ounces. The recipe calls for blank pounds of mushrooms and blank pounds of ground beef. So how many mushrooms does it call for? 8 ounces, but this is asking in pounds. So how many ounces is, what's the pound equivalent to 8 ounces? Well, if we look at our conversion table right here, I see 8 ounces, and that equals 1/2 of a pound. Okay, good. So the recipe calls for 1/2 a pound of mushrooms and blank pounds of ground beef. It says 12 ounces of ground beef. So if I look at my conversion table, 12 ounces equals 3/4 of a pound of ground beef. Okay, so now if we add the weights of all the ingredients, let's read our original problem again. Tyler is making a recipe that calls for 8 ounces of mushrooms. Okay, so 8 ounces of mushrooms is equal to 1/2 a pound. Okay, because it wants to know it in pounds. It doesn't want to know what the answer is in ounces. It wants to know pounds. Okay, 12 ounces of ground beef. So 12 right here equals 3/4 of a pound. So 3/4 plus 1.5. So we're going to go plus 1 plus 1/2. And this is going to tell us how many pounds, because the tomatoes were already in pounds, and 1.5 pounds of tomatoes. So let's add. We've got 1/2 plus 1/2 equals 1 whole, plus another whole, which equals 2. And after that, we've got 3/4 left over. So the dish will weigh about 2 3/4 pounds. Sorry, I had to pause the recording, students. Mrs. Harrington was laughing at me because she thinks I'm talking to myself while I record this. Okay, a recipe that Maggie wants to make indicates that there will be 3/4 an hour of preparation time, 2 hours of cook time, and 10 minutes for the dish to rest before serving. How much time in minutes should Maggie set aside for the recipe? Recipes do that. They say it's going to take 3/4 of an hour to prep, 2 hours to cook, and 10 minutes for the dish to rest before you can cook it. All right, so we need to now convert our time, hours to minutes. So 1 hour is 60 minutes. 1/4 of an hour is, think for a minute. Think of a clock if you need to. Okay, you can divide it into fourths. So from here to here is how many minutes? 15 minutes. You're okay. And 3/4 of an hour is 45 minutes. Okay, so Maggie will need how many minutes for the prep? So let's see, we've got 2 hours of cook time. Oh, sorry. Maggie will need blank minutes for prep. So 3/4 of an hour of preparation time. So 3/4 of an hour is 45 minutes for prep. 2 hours is 60 minutes times 2, or 120 minutes. Maggie will need 120 minutes of cook time. Maggie also needs blank minutes for the dish to rest, and it says 10 minutes for the dish to rest. So 10. So now we need to add our prep time, our cook time, and our rest time. So our prep time is 45 minutes, our cook time is 120 minutes, and our rest time is 10 minutes. So if we say 120 plus 45 plus 10. I want you to pause the recording and solve that very quickly. Okay, so 120 plus 45 plus 10. We've got 5 plus 0, which is 5. Then we've got 4 plus 2, which is 6, plus 1, which is 7, and 1 plus nothing else is 1. So she needs 175 minutes to prepare this recipe. That's a big recipe. Okay, for example 1 in your Math in My World, you guys need to be on this page in your My Math book. If you need to pause your recording and get there, do it now. Okay, example 1 says, the blue trail at the park is 3/4 of a mile long. The red trail is 1 1/4 miles long. Stella wants to hike both trails. How many feet will she hike in all? So we need to convert feet to miles and miles to feet. Do you guys remember how many feet are in a mile? Five tomatoes. 5280. 5,280. So 5 tomatoes are in a mile. Remember that. Okay, first thing we need to do is find the total number of miles. So we need to add 1 1/4 plus 3/4 equals 4 fourths plus 1/4 plus 3/4. Okay, 4 fourths plus 1/4 is 5 fourths plus 3/4, which is 8 fourths. 4 goes into 8 2 times, so 2. So Stella will hike 2 miles. Okay, now we need to convert the miles to feet. Remember, 1 mile equals 5 tomatoes, 5,280 feet. So we're going to multiply 2 miles times by 5,280 to find the total number of feet. So let's solve this. 5,280 times 2. 2 times 0 is 0. 2 times 8 is 16. 2 times 2 is 4 plus 1 is 5. Whoa, 5. And 2 times 5 is 10. So Stella will hike 10,560 feet in all. Good job, Stella. You rock. Okay, for example 2, Dominic weighed an apple and a watermelon. The apple weighed 5 ounces. The watermelon weighed 20 pounds. How many more ounces did the watermelon weigh than the apple? So step 1 is to find the total number of ounces the watermelon weighed. We know that there are 16 ounces in a pound, so we need to multiply 20 by 16. And we get 320. So the watermelon weighed 320 ounces. Now we need to find the difference in ounces. 320 ounces minus 5 ounces equals what? So 320 ounces minus 5 ounces equals 315 ounces. Whoops. So the watermelon weighed 315 ounces more than the apple. Okay, now for your guided practice. Here we go. Stan has 4 pints of milk. Gianna has twice as much milk as Stan. How many fluid ounces of milk does Gianna have? Okay, well I'm going to draw my gallon man, because anytime I see pints or ounces or cups or quarts or anything, I feel like I need my gallon man to help me. So pints, 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 and cup, 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 cup. Okay. And we know that there are 8 ounces in every cup. I can't write an 8 there, it's too small. So Stan has 4 pints of milk. So this is what Stan's got. Okay? Gianna has twice as much milk as Stan. So if she has 8 pints of milk, then that means Gianna's got this much milk. She has a whole gallon because 8 pints is equal to 1 gallon. Now, how many fluid ounces of milk does Gianna have? Well, we know that there are 8 fluid ounces in every cup. So, well, let's go over here. This is how they want us to solve it. Okay, so 4 pints times 2 equals 8 pints. Yep, we know that. Gianna has 8 pints. Gianna has 8 pints of milk. 8 pints times 16 fluid ounces, because there are 16 fluid ounces in every pint. So 16 times 8. 8 times 6 is 40, 48. 8 times 1, 8, plus 4 is 12. So 128 fluid ounces. So Gianna has 128 fluid ounces of milk. Okay. Number 2. Molly, good old Molly, my friend Molly, went to her grandma's house for 16 hours last weekend. This was 4 times longer than the time she spent at her grandma's this weekend. How many minutes was Molly at her grandma's house this weekend? Okay, well, we have hours here, and it's asking minutes, so that means we need to convert somewhere. Okay, so to find out how many hours, let's start with hours she spent at her grandma's this weekend. We need to figure out what's 16 times 4, because she spent 16 hours last weekend and 4 times that amount this weekend. So let's go 16 times 4. 4 times 6 is 24. 4 times 1 is 4, plus 2 is 6. So she spent 64 hours at her grandma's house this weekend. Now we know that we need to convert this to minutes, because it says how many minutes was Molly at her grandma's house this weekend. And we also know that there are 60 minutes in 1 hour. So if we take 60 times 64, we will get our answer. 60 minutes times 64 hours that she was there. Okay, everyone follow along with me. We're going to go 4 times 0 is 4. 4 times 6 is 24. Okay, now I go over to this place values. 0, my happy placeholder. Now I go 6 times 0 is 0. 6 times 6 is 36. And I add. Okay, so that means she spent 3,840 minutes at her grandma's house this weekend. All right, here's our math talk. Which operations did you use to solve exercise 2? Well, we used multiplication right here to solve number 2, right? We absolutely did. Okay, good. So here are your assignments for today. Eduardo, Connor, Chad, Zach, you guys do 3 through 9 odd and 10. Megan, Fernando, Yareli, Mikkel, you guys do 4 through 8 even and 9 and 10. And then everyone else, you guys need to do 3 through 5 and 8 through 10. And go ahead and get started.